guys, it's Miss Seville here, and I'm going to teach you about some trigonometry. And we're going to start with SOHCAHTOA. If you notice, we have these letters O and H, A and H, O and A. So I'm going to show you what those letters mean. So let's start with a right triangle. This whole lesson is going to be based on right triangles. And an angle we know as theta, or maybe we call it X, maybe they call it B, I don't know. But for this lesson, I'm going to call it theta, which is a Greek letter. So if we're talking about O is opposite. So the opposite side here, if we look at this triangle, here's the angle. I go across the triangle, the opposite side is over here. And then we're talking about the opposite leg, so it's not the hypotenuse, obviously. So that's the opposite leg. And I already said it, so let's label that. The hypotenuse is the side that's across from the right angle. Hypotenuse. Just hype. And the adjacent side is next to your angle. Adjacent means next to. And so it shares, the leg shares as a side of the angle. Adjacent. Okay, so now that we have our sides labeled, now we can define what sine, cosine, and tangent are. And these are new words, but we abbreviate them with just 3 letters. Sine is actually spelled S-I-N-E, but we abbreviate it with just S-I-N, which is fine. And tangent obviously is a 7-letter word. So let's talk about sine. So sine of theta, we can remember what that is because of this acronym, SO, O and H. So sine is just a ratio. It's a ratio of the opposite side over the hypotenuse. Cosine is just a ratio. It's the adjacent side, adjacent side over the hypotenuse. A over H. And this is all in your notes also. I just wanted to go over it with you. And then tangent is opposite over adjacent. I always think, okay, TOA, opposite over adjacent. Now there are other examples of triangles, and I just want to go over those different pictures. So some other examples of triangles where we can practice labeling opposite, adjacent, hypotenuse. Maybe your theta is up here. So if your theta is up there, a few things change. Your hypotenuse, of course, is always across from the right angle. But across the triangle from the angle, opposite the angle, is over here. This is your opposite side. Okay. Adjacent is the one next to it.
What are you doing, Mom?
Okay. Notice it's kind of flip-flop from this one. So it does kind of it depends on where your angle is that you're talking about. I'm going to draw another triangle and we'll practice this one.
I will try this one.
Oh, that doesn't quite look like a 90-degree angle.
Good. Good, Mom.
Sorry about my son. He's a little noisy this morning. Shh, Tanner, be quiet. Okay, here's the theta. Let's put the theta here. All right, so here's my hypotenuse. It's down here. Across the triangle, opposite the angle. is my opposite leg. And next to the angle is my adjacent leg. And that's how you label the sides. So next up, we'll do some examples. All right, so as promised, I said we would do some examples. So here's an example, and they ask us to find sine, find cosine, find tangent. And we are given two legs, 5 and 12. So the first thing we need to do is find the hypotenuse, because they did not give it to us. Now, some of you have these triples memorized. You know what if you see a 3 and a 4, then you know there's a 5, and you know a 3, 4, 5 triangle. And if you see a 5 and a 12, well, I won't give it to you right now, because I will show you the other way we can get to it. So if we needed to find the hypotenuse, we could call it maybe C. You would just quickly do the Pythagorean theorem. 5 squared plus 12 squared equals C squared. This is good review of that. So you get 25 plus 144 equals C squared. And when you add these together, you get 169 equals C squared. So when you square root both sides, you get 13 is C. So our hypotenuse is 13. That is a 5, 12, 13 triple.
What is 13?
Shh. Okay. No talking. Okay, so for sine, I want to think to myself, okay, SOHCAHTOA. Let me just write that out again. SOHCAHTOA.
I like this, Mom. I like this.
Thank you. Okay, so if we want to find sine, I'm talking about the opposite and hypotenuse. So here's my theta. My opposite side is here. I'll just put a little O next to it. My hypotenuse is here. That's my 13. And my adjacent is the one next to it. That's my 12. So for sine, I'm talking about opposite over hypotenuse. So the opposite side over the hypotenuse. So again, it's just a ratio. That's all you have to do for this example. For cosine, so right there's the cosine, A over H. So look at my triangle. My adjacent side is 12, hypotenuse is 13. 12 over 13. And for tangent, TOA, SOHCAHTOA. Oh, we can't see that part. O over A, so your opposite over adjacent, which is 5 over 12. Awesome. So for our next example, we're going to learn how to find a side. Now we have 7 as the hypotenuse, and we're trying to find the leg, which I called X. And this angle is 40. So this is how we set it up. You just identify what you know. So across from the 40, opposite the 40 is my X. So I'm going to label this opposite. The hypotenuse is obviously 7, so we can label that as hypotenuse. I don't even need to label my adjacent side. You just need 2 sides. Because when I have opposite and hypotenuse, I know that that means sine. Sine is opposite and hypotenuse. So right there, knowing this so, in these sides, I can set up an equation, which will allow me to solve for X. So sine of the angle, sine of 40 degrees, equals opposite over hypotenuse, X over 7. Now, sine of 40 is just a ratio, right? It's just a number. And on your calculator, you'll get a decimal, but that's okay. So anytime you have a fraction, right, we can cross multiply here. We can put this over 1 and cross multiply, which actually turns out pretty nice because x times 1 is just x. And then 7 times sine of 40, well, 7 times sine of 40. Notice I put the 7 first because I didn't want it to be like sine of 40 times 7. I don't want to end up taking sine of 280s. I always put the number or the constant in front of sine. So on your calculator, you'll notice we do have the sine button. But before you enter anything, you need to check your mode. Go to mode, and you can see here that I am in degree mode, and that's what you want to be in, is degree mode. Now, if you're using Desmos or the calculator on your Chromebook, that also has settings where you can change it to degree mode. You don't want to be in radians for this. Not for this course right now. 7 times sine of 40. So I entered it just like that, and we hit enter, and like I said, you get a decimal, and check your numbers. I got 4, almost 4.5. My hypotenuse is 7. Does it make sense that this is around 4.5? Absolutely, that works. If I got maybe 9.2, I would know I did something wrong. So always check your answer to be reasonable. And maybe we want to round to the nearest tenth, and we can do that. 4.49 would be 4.5. And there's no units here, so that's how you solve for a side.